chemical properties of carbonyl compound. There are 3 chemical properties of carbonyl compounds, but 4 if you include oxidation. The first one, nucleophilic addition of C-O. Secondly, reduction reactions. Finally, condensation with ammonia derivatives. In nucleophilic addition of C-O, there are 5 name of reaction or 5 additions in C-O. So the first one is addition of KCN acidified or NaCN in the presence of H+. Secondly, addition of water acidified, addition of alcohol, addition of sodium bisulphate, addition of Grignard reagent. It must be in situ preparation, which is it must be in the mixture. Addition of KCN in H+ or NaCN in H+, the reactant must be aldehyde or ketone and HCN. HCN cannot be used directly to react with aldehyde and ketone, so NaCN and HCl are used to mix with aldehyde or ketone instead of HCN. The product is cyanohydrin. KCN is also be used for the reactant. HCN is very volatile, extremely poisonous, and a very weak acid to produce enough Cn- ions for the reaction. So if we use directly HCN reacts with ketone or aldehyde, the HCN will be volatile. It won't react with aldehyde and ketone. So instead of using HCN directly, we use NaCN and HCl and or KCl and HCl. Therefore, NaCN or KCN is normally used with strong acids such as HCl, H2SO4. So this is aldehyde, it can be ketone as well, reacts with NaCN or KCN in the presence of strong acid. Here we use HCl. The product will be cyanohydrin. The name before cyanohydrin must be the name of the reactant. So in this chemical reaction, the reactant is acetaldehyde. So the product name is acetaldehyde cyanohydrin. Cyanohydrin means the CN single bond with C, cyano part, and OH hydroxyl group, OH attached to the carbon that attached to the CN. That is cyanohydrin, the compound that has CN attached to the same carbon with the OH. That's cyanohydrin. For addition of water in H+, the reactants or aldehyde or ketone can be OH- as well, as long as it is hydration addition of water. The product is hydrate because for carbonyl compound, hydration can be carried out in acidic or basic medium. For example, we use aldehyde here, it can be ketone as well, reacts with water, the hydration. In the presence of H+, the product name is hydrate or germ diol. Germ is germinal. Germinal, side by side, same carbon. Same carbon has 2 OH group. That's why it's diol, because you have 2 OH group on the same carbon. Which carbon? The carbon that has C double bond O initially. So this product, we call it hydrate or germ diol. Same goes if we use basic medium, OH-, hydration, the product is the same as in acidic medium, hydrate or germ diol. Addition of alcohols. Aldehyde or ketone reacts with alcohol in the presence of H+ to produce hemiacetal. Hemiacetal is when only one OR from alcohol, so this ROH, R group, OH group from alcohol, you remove the H, leaving O and R. So this one OR group, only one OR group attached to the carbon, which is C double bond O, and then this oxygen, the carbonyl oxygen, C double bond O oxygen, convert to become OH. That is hemiacetal. And then further addition of alcohol, this is when the question write excess alcohol. So when it is excess alcohol, you don't need to write down hemiacetal just from aldehyde to become acetal, or you can write the whole thing aldehyde, hemiacetal, and acetal. If the question doesn't put excess, you only need to write the product till hemiacetal. Further addition of alcohol from hemiacetal reacts with alcohol in the presence of H+. You replace this OH group with RO group from alcohol. So you must copy the R group from alcohol. So put OR group to replace OH. So it will become acetal plus side product water. Same goes for ketone. For ketone, the addition of alcohol initially in the presence of H+ will produce hemiketal. Only one OR group attached to the carbon, carbonyl carbon, C double bond O, and then this O convert to become OH. Further addition of alcohol from hemiketal will make this OR group replace OH group. So you have two OR group, and the product is called ketal plus H2O as a side product. Addition of sodium bisulphite. Reactants can be aldehyde or ketone and sodium bisulphite, NaHSO3. So this example use aldehyde, ethanol, reacts with sodium bisulphite. SO3 minus will attach to the carbon that has double bond O, and then the Na plus from here will bond it to SO3 minus, becoming SO3 minus Na plus. Make sure SO3 attached to the carbon that has C double bond O, and then this O part, you put H, this H add to the oxygen of C double bond O. So this is ethanol sodium bisulphite. Addition of Grignard reagent must be prepared in situ in the reaction mixture. In situ means in the reaction mixture. Methanol, the aldehyde that consists of one carbon only, produces primary alcohol. Other aldehydes means other than one carbon, aldehyde other than one carbon produces secondary alcohol. Ketones produce tertiary alcohol. That's for addition of Grignard reagent. So first we have to make Grignard reagent. Haloalkane react with magnesium. This is Grignard reagent. Reacts with methanol, aldehyde with one carbon only. It will become primary alcohol. So methanol in ether. So this is the alkyl part, the R group. It must attach to the carbon that has double bond O. So this R must attach, make new bond, must attach to the carbon that has double bond O, and then this double bond O becomes single bond O minus. You use the electrons in the bond give to the oxygen, making the oxygen has lone pair electron. So that's why O minus, and so the O minus will bind with MgCl plus. So Mg plus, MgCl plus. So this is the product of the methanol with ether, and then reacts with H2OH plus, becoming primary alcohol. So the MgCl part is replaced with hydrogen, becoming primary alcohol. This is from methanol. But from aldehyde, for other carbon other than 1 carbon, 2 and above, reacts with ether in acidified water. So this aldehyde, it will become like this first, and then it will become secondary alcohol. So COH, this C double bond O will become OH, C double bond O become OH, and this C double bond O take the R group of the Grignard reagent. It must attach to the C double bond O, this C. So this is the product of secondary alcohol. That's for aldehyde other than methanol. So 2 carbon and above. For ketone, this is ketone, reacts with Grignard reagent. So this is our R group. In presence of ether and acidified water, C double bond O becoming OH, the hydroxyl group, and this C must attach to the R group in the Grignard reagent. So you put here, and this is tertiary alcohol. From ketone becomes tertiary alcohol if you add Grignard reagent.